Hello, ladies and gentlemen. Welcome back. AP Statistics, Chapter 5, which is on producing data. Now, it's unfortunate that we are not in the classroom because there are some hands-on activities that I would like to do with you with this chapter to show you how some things work. But we'll do the best we can with this distance learning. Also, I want to remind you or tell you that there are some really good videos on the College Board website for AP Stats. I have not had the time to go through them and link them to Schoology yet, but eventually I am going to do that and give you some information on that. Also, on the College Board website, there are some what we call checkpoints, where you do problems to see how you're doing for each unit. And eventually, I don't want to put more work on you, but eventually I do need you to do those. I'll talk more about those after Thanksgiving. All right. Now, if you have not watched the video for experimental design on Schoology, I would advise you to stop watching this video now and go to Producing Data, Chapter 5.1, and going and watching this video against all odds first, okay? Designing experiments. I would advise you go do that before continuing with this video. All right? All right, so let's get back to this. So what I'm going to do is I'm going to go through a little PowerPoint. And I kind of like this PowerPoint. It was given to me many years ago by another teacher from Texas. And so let's take a look at this. It all has to deal with experimental design. All right, let's go ahead and let me get this thing running. Here we go. Okay, let me switch displays here because that's not the display I want. There we go. All right, here we go. Experimental design. Some definitions. And again, if you need to, pause the video and get some of these things written down. Observational study. And I'm going to repeat a lot of these definitions, so bear with me as I go through things, because some of this stuff I do repeat and I'll repeat in the other video. So observational study. Okay, obviously that is observe outcomes without imposing any treatment. Experiment. That's where you actively impose some treatment in order to observe the response. All right, now I have developed a new rabbit food, Hippity Hop. I claim, or it claims, it makes the rabbit's fur soft and shiny. And it increases their energy. And it's 100% of daily vitamins and essential oils. Can I just make these claims, ladies and gentlemen? I think you know the answer to that, right? No, I cannot just make these claims. Companies cannot just make claims. That's how sometimes they get sued if they don't have data to back it up. What must I do to make these claims? Well, I must do an experiment. Who or what should I test this on? I think that would be rabbits. What do I test? The type of food. 3, experimental unit. That is the single individual, that can be a person, animal, plant, etc., to which the different treatments are assigned. Again, that's an experimental unit. What is a factor? A factor is the explanatory variable. Level, a specific value for the factor. Okay, level is a specific value for the factor. And obviously we have the response variable. That is what we measure. The treatment, a specific experimental condition applied to the units. All right, I plan to test my new rabbit food. What are my experimental units? Must be the rabbits. What is the factor? Factor is the explanatory variable. Oh yeah, it's the type of food. What is the response? How well they grow. All right. So I've got my hippity hop rabbit food. I've got my rabbit. Okay, it's my lucky rabbit Lucky. And I tested it on Lucky. Since Lucky's coat is shiny and he has more energy, then hippity hop is a better rabbit food. Well, you need a control group, folks. A group that is used to compare the factor against. It can be a placebo or old or current item. Think of what's going on right now, folks, with COVID-19 and all of the experiments they're doing. They're doing this exact thing right now with the vaccines. They've got all these people they're testing it on, and they've got a control group that are receiving something else, like a placebo or an old or current item, okay, because you have to have something to compare it to. Okay, the placebo is a dummy treatment that can have no physical effect. Okay, oftentimes when they're testing a new medicine, you might get a sugar pill. They call it a sugar pill. It's a dummy pill. You don't know if it's real or not. All right, so we're with the hippity hop, we're going to have the old food and we're going to have the hippity hop food. All right. Now I use Lucky and my friend's rabbit, Flash. Lucky gets hippity hop food and Flash gets the old food. Wow. Lucky is bigger and shinier, so hippity hop is better. Well, not quite so fast. We need more rabbits, folks. We need more rabbits. We can't just compare it to our friends. Our friend's rabbit probably was already, you know, not as big and all of that stuff. So we're going to have some rabbits. We're going to have like 10 rabbits. The first 5 rabbits that I catch will get hippity hop food, and the remaining 5 will get the old food. Okay, let's see what happens. So I see my 10 rabbits down there. I catch these 5, and then the other 5 get the old food. Well, something looks a little weird here, ladies and gentlemen. Okay, well, again, the hippity hop rabbit scores higher, so it's a better food. Well, look at those rabbits. The rabbits that got hippity hop are already, you know, they're kind of chubby already, and they're a little bit slower, and I think I caught them easier. So that's not the best method. All right, the best method, ladies and gentlemen, for picking who gets what is to assign numbers and then randomly pick them. This is huge in AP statistics. Random assignments. Okay, random. All the other ways were not random. Okay, so I'm going to number them 1 to 10, and the best option is to use like a hat, put the numbers in a hat and pick out the numbers. That is the best way. Now, there are other ways we're going to talk about. A simple random table. There's a table of random digits in the back of your book. Technically, it's not random, but we're going to use that table because they often like to ask questions about that on the AP test. So I got to teach you how to use that random digit table, and I'm going to teach you how to use the random digits on the calculator, but not today. All right, so I'm going to place those numbers in a hat. The first 5 numbers pulled from the hat will get the hippity hop food. The remaining 5 will get the old food. All right, so the first one I pick out is a 9. So 9 goes into the hippity hop. The next number I pick out is a 7. So the 7 goes, that rabbit goes into the hippity hop. Next one is 5. Next one is 8. Next one is 3. Okay, and now the other rabbits are going to go to the old food. All right. I evaluate the rabbits and found that the rabbits that eat hippity hop are better than the old. Now I can make that claim if it is true, okay? Because I did all of the appropriate things to randomly pick them and then test, and I had a control group. All right, 10. Blinding. The method used so that units do not know which treatment they are getting. Okay, usually a subject does not know what they are getting. Okay, because if you know, that could actually affect the results. Okay, oftentimes they use a double blind. That's where neither the units, okay, nor the evaluator know which treatment a subject received. So the person giving you the treatment also does not know. Okay, again, they're doing all of this with the COVID-19 stuff right now. All right, hippity hop. Hippity hop rabbit food makes fur soft and shiny and increases energy for all types of rabbits. Well, you'll notice it says all types of rabbits. It looked like I tested it basically on one. There's all kinds of rabbits out there, folks. So, I really can't make that claim, okay, on all rabbits. I can really only claim it on the ones that I tested. So it looked like I could only claim that for the white rabbits. Okay, we've got all kinds of rabbits. We got rabbits with long ears, long droopy ears. We've got, okay, I don't even know all the names for rabbits, but we can't claim it for all rabbits. We can only claim it for the type of rabbits that we experimented on. That is really important to know. Okay. Now, some principles of experimental design. Okay, and this stuff is in your book. Please read the book. Control of the effects of extraneous variables on the response by comparing treatment groups to a control group, placebo group. Okay, that's control. You should be able to replicate it. Replication of the experiment on many subjects to quantify the natural variation in the experiment. Okay, usually you don't just run the experiment once, you run it several times, and you've got to be able to replicate it. Randomization, the use of chance to assign subjects to treatment. Again, if I'm going too fast, please pause, rewind. So, folks, the only way to show cause and effect is with a well-designed, well-controlled experiment. Let's say it again. The only way to show cause and effect is with a well-designed, well-controlled experiment. One more time. The only way to show cause and effect is with a well-designed, well-controlled experiment. All right, let's look at some examples. A farm product manufacturer wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizer. 15 similar plots of land are planted with the same type of seed but are fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. Okay, what are the experimental units? Plots of land. What are the factors? Type of fertilizer. Remember, factors are the explanatory variable. Levels. Well, there's 3 types. A, we're going to call them A, B, and C. What's the response? What are we measuring? The yield of the crop. How much did it produce? Now, how many treatments are there? 3, because there's 3 types of fertilizer. 3 treatments going on. Example 2. A consumer group wants to test cake pans to see which works the best, bakes evenly. It will test aluminum, glass, and plastic pans in both gas and electric ovens. Okay, what are the experimental units? The cake batter. Okay. What are the factors? What are the explanatory variables? There's 2 of them. Type of pan and type of oven. Levels. Well, there's 3 levels for the pans because there's aluminum, glass, and plastic, and there's 2 levels for the oven, electric and gas. What's the response? What are we measuring? How evenly the cake bakes. Now, the number of treatments. 6. 3 levels of pan, 2 levels for oven. 2 times 3 is 6, ladies and gentlemen. All right, let's look at another one. A farm product manufacturer wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizers. 15 similar plots of land are planted with the same type of seed but are fertilized differently. That sounds familiar, doesn't it? At the end of the growing season, the mean yield from the sample plot is compared. Now, the questions are different. So this is what we saw a couple of examples ago. Why is the same type of seed used on all 15 plots? It is part of the controls in the experiment. Okay, we use the same seed as a control. What are other potential extraneous variables? Well, the type of soil, okay, the soil might be a little bit different in one spot than another spot. The amount of water it gets in one spot compared to another spot. There's all kinds of, the shade, is there shade? Are there trees nearby? Is it close to a swamp? Okay, there's all other potential extraneous variables that we don't know about. Okay, and we're going to talk about how to control some of that with a block design, but not today. Okay, does this experiment have a placebo? Explain. No, a placebo is not needed in this experiment. Okay, it's kind of hard to have a placebo when you're talking about producing yield for a crop. Okay, now with medicine and things like that, then a placebo makes more sense. But in this case, there's no placebo. Right, now this next diagram is very important that you know how to set up, and there's more detailed ones in the book. Please look at those. So this is what an experimental design looks like, completely randomized. All experimental units are allocated at random among all the treatments. So on the left side, we've got the explanatory variable, and then we've got the treatment group 1, treatment group 2, treatment group 3, and those are all the units are randomly put into those, and then at the end we compare those variables. Okay, so let me show you a little bit more detail. So again, we're going to randomly assign to the different treatment groups. All right, and then we compare it. Now, let's look at this. So here we have 4 treatments, and you'll notice we've got some smiley green faces. I think that's green or an awkward blue. Okay, and pink faces. All right. Now, I'm going to randomly assign experimental units to the treatment. So I'm randomly assigning. All right, still randomly assigning. All right, that is a completely randomized design, folks. Randomly picking for each treatment group. All right, so I'm going to stop at this slide because we're going to be talking about a block design later on in a different lesson. So I'm going to stop with this slide, but I'm not done with this presentation. I will finish that in another lesson. All right, so let's wrap this up with a few things from here. Again, I'm going to repeat some of these things that I said in the other one. So here we go. So again, we already saw this observational study versus experiment. Okay, this is found on page 329 in your book. Make sure you know those definitions. Again, you can pause this if you need to. I'm going to keep going. Population and sample. Okay, you need to know the difference between a population and a sample. It should be obvious. We've been talking about it. Okay, it's on page 330 in your book. Sampling versus a census. Okay, sample versus a census. Remember, sampling involves studying a part in order to gain information about the whole. The census, which the United States just did, and I don't think they did a very good job of it, but that's my opinion, A census attempts to contact every individual in the entire population. Okay, volunteer response. Now, ladies and gentlemen, voluntary response, well, let me read through it instead of repeating myself. A voluntary response sample consists of people who choose themselves by responding to a general appeal. Folks, voluntary responses samples are biased because people with strong opinions, especially negative opinions, are most likely to respond. Please keep that in mind, that voluntary responses are biased because it's usually the people with strong opinions, usually negative, that respond. All right, we're going to end with this one, convenience sampling. Okay, choose individuals who are easiest to reach is called a convenience sample. For example, if we were in school and I was wanting you to have students do a questionnaire, it would be very convenient for you to either ask people during lunch or just ask people in one of your other classes. Okay, that would be very convenient. All right, so it just makes it real easy to reach people. Now, there are some biases with convenience sampling. Okay, like if Burger King wanted to do a survey and Burger King just surveyed people at Burger King, I don't think the results would be very reliable, would they? Because the people at Burger King that are going to Burger King are going to probably favor Burger King. So keep in mind that there can be some drawbacks to convenience sampling because you're not always going to get a random sample. And remember, random sampling is very, very, very important. All right, well, that is it for this first lesson, ladies and gentlemen. We will pick this up again in the next one. All right, see you later.